Thank you for joining me in this presentation. I'm Aluoro Occult from Kenyatta University. I'm presenting on genotypic characterization of HBV among low-risk populations in Nairobi. Hepatitis B virus causes a high morbidity and mortality, largely due to its ability to cause hepatitis, liver cirrhosis, and hepatocellular carcinoma. Most studies on HBV in Kenya have focused on epidemiology. The HBV genome, however, is prone to mutations which can lead to OBI, which has been associated with the development of cirrhosis and HCC. As well, this mutation results to drug resistance among individuals. The genotypic diversity within HBV results to varied characteristics from one genotype to another, especially in drug sensitivity. A problem statement. Hepatitis B virus screening at NBTS involves use of CMIA to detect HBsAg. This method does not tell of the HBV genotypes, neither does it screen for HBV DNA. As well, NBTS does not have a follow-up mechanism for the negative patients to ascertain those who are true negatives. Hence, those who are false negatives remain at risk of disease progression and may as well pass the infection to the recipients of their blood and blood. There was need for knowledge to understand the circulating genotypes and the mutational adaptations that result in drug resistance and escape of the conventional screening techniques to ensure that those who are screened for HBV get the correct results and the right antiretroviral therapy. These findings, hence, it's our hope that will help improve the quality of life and make management of hepatitis B virus better. In our research questions, we ask, what is the prevalence of occult HBV infections? What are the circulating genotypes of HBV and their phylogeny? What are the escape mutations associated with the drug resistance and diagnostic failure? And what are the demographic factors associated with the HBV infection? Our study objectives were meant to answer these research questions in the previous slide. However, our study does not look into data on HBV viral loads and liver enzymes, particularly of the affected individuals. This therefore made it hard for us to provide any correlation between our findings and the clinical outcomes of the affected patients. The study as well did not conduct a follow-up on the individuals, particularly those with OBI, to monitor their disease progression. We therefore do not report on any clinical disease progression for OBI patients. Our study employed a cross-sectional study design, and all those donors who met the donation requirements as provided by KNBTS were included in the study, while those who didn't meet were excluded. Our sample size was calculated using modified Fisher's formula, and we used a prevalence from Karubo et al. Study of 2015, which reported a prevalence of 13.3. The samples were collected at the point of donation in both plain and EDTA-containing vacutainers. The sample from plain tube was used to extract serum for CMIA method to screen for HBsAg, while plasma was used to extract genetic material that was amplified using PCR and sequenced using Sanger's method. The resulting sequences were then analyzed for drug resistance and genotypic characterization done using BioEdit, MegaX, Geno2Pheno, and NCBI BLAST. Data analysis involved bivariate analysis to determine correlation between demographic factors and HBV infection, particularly where the p-value was less than 0.005. We report an HBV prevalence of 2.3%, with 3.3% in females and 1.69% in males. We as well report that we found an association between age and HBV seropositivity with a p-value of 0.001. We report an occult HBV infection prevalence of 2.4% in this population, and we as well report genotype A, subgenotype A1 to be exclusively prevalent in this population. According to our phylogenetic tree, as displayed hereby, you note that all our sequences displayed in red fall within the band of genotype A, subgenotype A1. All reference sequences are indicated in black, and they were obtained from the gene bank. We report a number of mutations, particularly conferring resistance against Lamivudine, and notable is mutation M129L and V163I. They are the most prevalent mutations, and our study agrees with the current regimen that Lamivudine may not be used as a primary drug in management of HBV. We report that genotype A is circulating in Kenya, and we report occult HBV infections in a population not previously reported. These study findings hence necessitates there is need to review our national protocol for screening of HBV to ensure safety of blood and blood products that we give to our patients. Additionally, this study reaffirms the need to incorporate nucleic acid tests in HBV screening. Kindly note that part of these study findings have been published by the Springer Nature in Virology Journal. You may contact me on the contacts indicated on the screen. I thank you.